Welcome to the Deep Dive, the place where we cut through the noise and get straight to the foundational ideas shaping tomorrow. Today, we're not just looking at a technology. We're examining a blueprint that promises to solve some of the most endemic structural failings of our current digital life. We are diving deep into Holochain, an architecture that is, and I don't use this word lightly, truly a paradigm shift.
Yeah, and we've got a fantastic stack of sources here that really challenge the very axioms of internet infrastructure. Whether you think the client-server model is, good enough or you're all in on decentralized blockchains, these sources suggest we've been building the digital world, well, wrong. We're moving beyond structures of control and exploring models of natural resilience.
Okay, let's start there. Let's start with the absurdity of the current digital landscape. We've built this world that is utterly dependent on central control. We call it the client-server model. And every single piece of data, every interaction, it all funnels through these massive centralized platforms.
It's the digital Tower of Babel. That's the perfect analogy. We've somehow managed to put all the digital eggs, the chickens, the farmers, the entire digital food supply chain into one single, massive, vulnerable glass structure, the server farm. And if that structure goes down, or if the single corporation controlling it decides to, change the rules or monetize your data in a new way, you are completely stranded.
And how efficiently we engineered that single point of failure. I mean, it's almost funny. We thought it was marvelous. A single server farm outage, maybe because of a rogue software update or, heaven forbid, a misplaced backhoe cutting a fiber line. And suddenly billions of people lose access to their history, their money, or their means of communication. Truly peak reliability, we were told.
And the reaction to that vulnerability was the advent of blockchain, which, in trying to solve the problem of centralized trust, kind of overshot the mark and created a new problem of global spectacular inefficiency.
Oh, that's where the sarcasm really kicks in for me. Instead of trusting one central authority, we now demand that potentially billions of independent computers globally must stop everything they are doing and simultaneously agree precisely and expensively on one single, globally agreed-upon truth for even the simplest action.
It's the equivalent of demanding that if Alice wants to borrow a library book, every single person on Earth has to halt their day, verify Alice's ID, confirm the book's availability, and then record the loan on their own personal, heavily encrypted, globally synchronized ledger before she can even step into the reading room. The computational cost, the latency, the resulting environmental impact of that process are, frankly, self-defeating for mass adoption.
It's a solution that scales until it becomes popular.
Right.
And then it instantly collapses under its own weight because the cost of maintaining that global coherence becomes just.
And what our sources illuminate today is an architecture that sidesteps both of these fundamental flaws. Holochain proposes a really foundational shift, designing digital systems modeled not on rigid towers or immutable ledgers, but on life itself, on dynamic, local, self-healing ecosystems.
And that is our mission for today. To understand Holochain's core architecture agent centricity, source chains, and the distributed hash table using simple, immersive, natural analogies, we need to demonstrate why this radically different design is, I think, absolutely essential for building a sustainable, resilient, and truly peer-to-peer digital future.
Okay, so the core philosophy of Holochain, it begins with this axiom. There is no single global truth. There is no unified system state that has to be maintained everywhere all the time. Reality, whether you're talking about biology or digital systems, is fundamentally local. It's defined by local observations and local actions taken by autonomous individual participants.
Let's ground this immediately in our primary analogy, which I love, the forest. So forget the idea of a centralized data center being the single, massive, vulnerable tree. Holochain views the network as a dense, robust forest ecosystem.
Exactly. In this forest, each tree, or agent, which just means the user, is an autonomous unit. It manages its own health, its own history, its own resources, the coordination and shared reality needed for the forest to thrive. That happens locally, peer-to-peer, like the vast network of fungi, the mycorrhizal network exchanging resources and warnings beneath the forest floor. There is no single central tree dictating the water schedule for everyone else.
The paradigm shift here is profound. Holochain is revolutionary because it places the user at the center. This is what they call agent centricity.
When you participate in a Holochain application or an HAP, you are not accessing a distant server. You are running your own copy of the application's entire backend code. They call it your cell. It runs directly on your device. This cell is bound to your unique agent ID. You control your identity, you store your private data, and you possess the processing power.
This flips the centralized architecture entirely on its head. Instead of, renting a room in someone else's mansion and hoping they don't evict you or raise the rent,
Yeah.
you own your own house outright. You possess the infrastructure, the security, and the storage responsibility. This local autonomy is the bedrock for true digital agency.
Right. It all starts with the agent.
So the user, the agent, is the autonomous core. But what defines the agent? How does the network know what rules this specific digital organism is operating by? And how does it keep a verifiable history?
Okay, now we enter the realm of sort of genetics and history. We need to define the immutable rules of the game and the organism itself. And these are the two core architectural components running locally on the agent's machine.
First, we have the DNA. This is the bundle of executable code that forms the fundamental social contract. It's not just the application logic. It serves as the rules of the game against which all peers can perform validation and enforcement.
Yeah, think of the DNA as the species genetic code. It defines the blueprint for the entire network, the access and integrity layer around both personal and shared data. And within the DNA, developers define these executable modules called zooms, which is short for chromosomes.
And this is where the technical detail gets foundational, I think. We have to distinguish between two types of zooms, right?
We do. First, you have the integrity zooms. These contain the critical validation logic, the core rules of the game. Once these integrity rules are established, they are cryptographically signed into the DNA and are completely immutable.
So that's the physics of this universe. You can't change it.
You can't. The other type is the coordinator zooms. These contain the mutable application logic, defining how the user interface interacts with those immutable rules set by the integrity zooms. So if you want to change the look of the app, you update the coordinator zooms. But if you want to change the underlying rules, say moving from one person, one vote to weighted voting, you can't just push an update.
You have to fork. As the sources note, modifying an integrity zone requires cloning the DNA. And that effectively creates a new, separate network with an entirely new history in shared database. It's like branching evolution. You've created a new species that cannot interact with the old one. And that ensures the integrity of the original network is never compromised by forced unwanted rule changes.
Exactly. And the cell, as we said, is the running instance of that specific DNA, bound to your agent ID. So if you participate in 3 different decentralized chat groups and 2 financial apps, you have 5 isolated cells running on your device, each defined by its unique DNA. And this is key. All functions are run locally on your machine from your perspective. No external server is mediating your existence.
Okay, so we have the organism, the cell. Now, for its autobiography, the source chain. This is the agent's immutable, chronological, append-only journal of every single action performed within that specific cell.
The analogy here is perfect. The rings of a tree. A tree adds a new ring every year, and that historical record is indelible. You can't just cut it out without leaving a glaring, verifiable gap. Similarly, once an action, be it posting a message, transferring a token, updating a profile, once that's committed, it's cryptographically signed by the agent's private key and permanently written to the end of the chain.
And that cryptographic signature is the royal seal. It's the intrinsic proof that you, the agent, performed that action. And the history is secured because each new action references the cryptographic hash, the unique digital fingerprint of the previous action.
That chain of references means that if you try to modify even a single character in an old record, the hash changes, which then invalidates the hash of the next record and so on down the line. The entire subsequent history is broken. The integrity of the data against external tampering is mathematically guaranteed. We're literally using advanced mathematics to make digital records harder to alter than physical stone tablets.
Okay, but let me inject some healthy skepticism here, because the sources raise a critical point. This guarantee is only for intrinsic data integrity, right? That the history hasn't been tampered with by a third party. But what if the agent themselves is dishonest?
That's the crucial distinction. An agent could theoretically try to rewrite their own history, like trying to carve a new date into the tree's rings. They could recreate all the subsequent actions, recalculate all the hashes, and re-sign the entire chain.
Right, and since they own the keys in the source chain, they could theoretically present a perfectly valid but fabricated alternate history to the network. How do we ensure that the digital organism hasn't secretly grown a parallel, malevolent set of rings?
That's why the source chain gives the agent intrinsic integrity proof of authorship. But it does not guarantee the agent's honesty. It merely sets the stage for the community to check your work. Before any action can be shared publicly, the immutable personal history has to be established. The chain starts with genesis records, the hash of the DNA, your public key, and this establishes the foundation of your accountable existence. This foundation is necessary for the next step, which is bringing the community in for external validation.
Right. It forces us to treat digital speech with the same weight we used to treat writing on paper or carving in stone. And that's a significant cognitive adjustment for a generation that's used to instant deletion and revision.
A huge adjustment.
So we have the individual, autonomous, verifiable agent, the tree with its indelible rings. But now we face a pretty practical problem. If my local device breaks or if I go offline, all that historical data, all those actions, they just vanish. For an application to be useful, it needs resilience, availability, and a shared space for connection.
This is where the distributed hash table, or DHT, enters the picture. The DHT is the shared distributed database where public actions, the data meant to be shared with the community, are published, stored, and most importantly, validated by the peers.
So instead of a central library storing all the books, we shift to the analogy of a cloud of witnesses, or the collective, decentralized memory of the forest floor. The community collectively and redundantly stores pieces of data, ensuring it persists even if the original author goes offline or the device is destroyed.
The underlying mechanism for the DHT is really elegant. Every agent and every piece of public data they publish gets a unique address. It's essentially a massive random number derived from its cryptographic hash or public key. And all these addresses exist within the same vast numeric space.
And here's the foundational mechanism of Holochain's sharding. Agents don't store everything, which is what blockchains typically demand. Instead, each agent chooses to be an authority for a very small arc or range of data addresses that are nearest to their own public key.
Yes, the assignment is based on cryptographically derived distance. It's entirely random and impartial, like assigning citizens to jury duty. This balances the data load across the network and ensures that no single group can self-select to control data storage for a specific address range.
So when I publish a public action, let's say it's entry M, look at my list of known peers and find the ones whose cryptographic addresses are numerically closest to M. These are the authorities for that piece of data. I send them the data, and they are now responsible for storing it and ensuring its availability.
And the discovery process is iterative and highly efficient. If I ask my immediate neighbor, let's call him Fred, for entry M, and Fred realizes he isn't an authority for that address, he doesn't just say no. He suggests the peer he knows who is numerically closer to M. So the request iteratively hops across the network, always getting closer, until the authorities responsible for storing M are found.
Okay, that iterative lookup avoids the need for a central index. But I have a skeptical question. Does this iterative search introduce latency problems, especially in very large networks? Couldn't it be slow compared to just querying a central server?
That's a fair challenge. The iterative search is crucial for decentralization, but Holochain addresses latency by relying on two factors. First, the speed of local network gossip, and second, the density of the network. The more robust the peer connections, the fewer hops are required. It trades the guaranteed high speed of a single server for the guaranteed resilience of a decentralized network. And it minimizes latency through efficient routing based on proximity in the address space.
Okay, so once the authorities receive the data, they don't just store it. And this leads us to what I think is the absolute core innovation of Holochain Trust, peer validation. We can think of this as the digital immune system.
This is the critical distinction from traditional blockchain. Blockchains enforce global, expensive consensus before the action is finalized. Holochain focuses on local, immediate action written to your source chain, followed immediately by community verification.
Right. So when an authority node receives data to store, it acts like a white blood cell. It runs the diagnostics, it accesses the immutable integrity zones from the shared DNA, and it checks two things. Is the data structurally correct? And importantly, does the author's source chain history support this action? Does the tree ring history allow this move?
If the data passes the validation rules, the authority node signs a validation receipt. It's a cryptographically signed attestation that the entry is healthy, it adheres to the rules, and it's now ready for storage and gossiping. This receipt confirms the entry's integrity within the shared space.
But what happens if the data fails? If the agent tried to publish a conflicting transaction, or if their source chain reveals they broke the established rules?
If the data fails, the validator issues a warrant. This warrant is the antibody. It's a cryptographically signed attestation, a piece of evidence that the author is a bad actor who has violated the community's DNA. And this mechanism creates a self-healing system.
Wait, I need to pause here for a moment. This sounds powerful, but isn't there a risk of creating I don't know, filter bubbles or malicious banning campaigns. If the community is the police force, couldn't a group of peers conspire to issue false warrants against an individual they dislike, effectively silencing them?
That's a crucial, critical point. And the system mitigates this because the DNA validation rules are public and auditable. A warrant is useless unless it is demonstrably true according to the shared rules. So if an honest peer reviews a malicious warrant, they can verify that the bad actor actually followed the rules, and the malicious warrant itself becomes evidence of the validator's bad behavior.
So the system is designed to turn the table on malicious validators. Their own signed warrant provides immutable proof of their own deceit if the underlying claim is false.
Exactly. The power of the warrant is its transparency. Peers can use a confirmed warrant to justify defensive action, refusing to communicate with the rule breaker, refusing to store their data, and deleting any data they authored from their own local DHT slice. There is no central global police force ejecting the actor. Instead, coherence is maintained by local, decentralized consequence. The network functions as an adaptive, self-healing social organism.
This decentralized consequence also makes the system incredibly resilient to physical failure. We had that great example in the source material of the island cut off by a hurricane.
Right. When the mainland and the island can't communicate, the network partitions. Suddenly, the neighbors responsible for storing certain data addresses are unreachable, but the network doesn't halt. Islanders can still talk to their physical neighbors using the app. The local DHTs autonomously adjust, often enlarging their storage arcs temporarily to compensate for the missing nodes, ensuring no data is lost and the application remains completely operational on the island.
And when the radio towers are rebuilt and the network heals, the new data just syncs up gracefully. This resilience against network partitioning is absolutely foundational for building reliable global infrastructure. It's so different from systems that just freeze when global consistency is lost.
And before we move on, let's quickly address the paradox of immutability and application utility. We said the source chain is permanent, like tree rings, but users demand update and delete functionality.
Right, so it can't actually erase the rings. Holochain solves this by simulating mutability.
Precisely. If Alice posts a message and later decides to delete it, she doesn't reach into the distributed database and scrub the original entry. Instead, she commits a new signed action to her source chain, a special record that says, "Ignore entry X, I hereby withdraw this information."
It's like taping a correction onto the tree's rings. The original data remains, permanently committed, but the application's coordinator zones, the user-facing logic, are designed to filter out anything that has been superseded or withdrawn when displaying the feed.
This permanence forces better behavior. I mean, developers have a responsibility to communicate that shared data is immutable and lives redundantly in caches and backups across the DHT forever. It mandates that users exercise responsibility regarding what they share publicly, shifting the burden of censorship away from the platform and onto the user's initial choice.
We've built the autonomous tree, the agent, and its self-healing community, the DHT. But now we are left with a massive technical challenge of just finding things. If data is stored only by a random hash address, how do we find related content or start a useful query like, show me all posts by agents I follow?
You can't. The addresses are random, unforgeable numbers. You can't perform arbitrary SQL-like queries on the DHT because the data is cryptographically scattered across thousands of nodes. Retrieving it by hash alone tells you nothing about the content or context.
So in our forest analogy, we have trees scattered randomly by cryptographic address. We need pathways and recognizable signposts, a map to navigate this distributed reality.
And Holochain introduces two structures that transform the random DHT address space into a fully navigable graph database, links and anchors.
Okay, a link is simply a unidirectional pointer. It connects a known base address, like my profile page's hash, to an unknown target address, like the hash of my newest post. And the link itself is stored by the authorities responsible for the base address.
This is a radical efficiency gain. If you want to find all of Alice's posts, you just query the few authorities responsible for storing Alice's profile address, and they hand you the list of links to all her posts. You don't have to query the entire global network.
And anchors serve as those recognizable signposts that start the journey. An anchor is a small, easy-to-calculate entry, often just a constant string like all users or a simple username like Alice Ukulele. Since the input is constant, the hash address of the anchor is easily calculated and known by everyone.
We can use the music sharing case study now. Alice, the musician, registers her username at Alice Ukulele and links it to her agent address. Crucially, she also links her username to the hard-coded All Musicians anchor.
And this enables revolutionary decentralized data discovery. So listeners can calculate the hash address of all musicians, query the few authorities responsible for that anchor, and instantly retrieve the links to all registered musicians, including Alice's username.
Once they have Alice's username, they follow the link to her agent address. From there, they follow the links from her agent address to her albums, and then links from her albums to genre tags. This dynamically builds a navigable graph structure out of randomly sharded data, all while remaining fully decentralized and validated by the local peers.
This architecture ensures that data discovery isn't dependent on some massive, expensive, centrally indexed search engine. It's dependent on localized, peer-validated pathways, the self-organizing social fabric of the forest floor.
Mhm. And this complexity of interaction brings us to the ultimate challenge: coordination. How do two autonomous agents, say Alice and Bob, make an atomic transaction or sign a complex contract that requires synchronicity without resorting to a central server or waiting for the entire globe to achieve finality?
Blockchains solve this with global consensus, which means high latency. Holochain needs something entirely different. They call it scaled consent.
The mechanism is countersigning. This process allows two or more agents to simultaneously and atomically write a single action to both of their source chains, ensuring they achieve a shared understanding of each other's history and the resulting outcome.
This is the double handshake analogy, but with cryptographic teeth. The transaction process requires several steps to ensure atomicity.
Step 1. Alice prepares the proposed action, like sending tokens to Bob. Before submitting anything, both agents must run a pre-flight validation check. They momentarily lock their source chains, preventing new actions, and locally run the DNA's validation rules against the proposed transaction to make sure it's valid from both their perspectives. Does Alice have the tokens? Is Bob's address correct?
Okay, step 2. They tentatively publish the signed proposed action to the DHT authorities as a temporary record, but they don't finalize the commitment on their personal source chains just yet.
Step 3. They wait for evidence. Only when they both receive the full set of cryptographically signed actions proving the other party has also tentatively published and validated the transaction do they proceed to step 4, which is committing the action permanently to their respective source chains and publishing the final records to the DHT.
And if the pre-flight validation fails, or if the session times out during the tentative publishing stage, they just back out, unlock their chains, and the temporary data is discarded. And the entire process only involved Alice, Bob, and maybe a few witnesses necessary for validation.
This is the groundbreaking leap: micro-consensus or scaled consent. It proves coordination is possible when needed, without sacrificing local autonomy or paying the enormous cost of global finality. This highly contextual implementation of Byzantine consensus avoids the massive latency issues inherent to platforms like Ethereum or Bitcoin, where state changes require mining and massive network agreement.
This naturally leads us back to the philosophical goal here. How does desirable social coherence evolve? Centralized systems force coherence through rigid, often extractive power structures. Blockchains try to force total coherence everywhere, which is like the digital equivalent of a command economy.
Holochain enables coherence through emergent order. We can go back to the analogy of the swarm of starlings, or a murmuration. No single bird is calculating the path of the entire flock. Each bird is merely following simple, local rules relative to its immediate neighbors. Stay close, don't crash, match speed.
And the result of these simple, localized actions validated by local peers is large-scale, adaptive, and highly coherent group behavior that is infinitely more resilient than a central flight plan would ever be.
This is why Holochain is absolutely revolutionary. It provides infrastructure for engagement spaces, HAPs, with custom evolvable rules, the DNA. Coherence is achieved not through forced uniformity, but by agents taking independent, autonomous action based on local information, trusting that their action is instantly verifiable against the shared local rules by the digital immune system. It allows the social fabric to dynamically organize itself based on simple, local principles.
Look, we've covered a tremendous amount of detail, moving from the individual agent to the complex social dynamics of the network. Let's maybe just consolidate the 3 foundational pillars of this architecture.
Okay, first, agent centricity. You are the autonomous tree. You're running your own software cell, controlling your identity, and possessing your own infrastructure.
Second, the source chain. You maintain your immutable, verifiable history, the unforgeable tree rings, which serves as the intrinsic source of all your shared data.
And third, the DHT and peer validation. The network acts as a decentralized, self-healing immune system, the cloud of witnesses, constantly validating and distributing data, using warrants like antibodies to detect and isolate bad actors based on the public rules of the DNA.
So now we have to articulate why this technology isn't just an alternative, but why it must be used to construct the future of the digital world, replacing the brittle structures we've relied on for decades.
The necessity, it really stems from resilience and availability. By distributing processing, storage, and security risk across the entire network, you eliminate central points of failure. The network becomes anti-fragile. The island surviving the hurricane is the perfect metaphor. The network can operate, heal, and adapt, even when large sections are compromised.
And then there's the matter of affordability and scale. Holochain fundamentally addresses this success collapse issue of blockchain. Because it eliminates the requirement for global consensus, hosting costs don't scale with traffic. The system is designed to handle increasing popularity without increased exponential load on every single node.
Holochain is fundamentally more efficient because it only enforces rigorous consensus, that costly validation step, where it is strictly necessary, usually between two consenting parties via countersigning. This radically lowers the storage and computational requirements, making true decentralized applications feasible even on lightweight portable devices like standard smartphones.
And crucially, this delivers true digital agency. It reverses the fundamental power imbalance of the centralized web, where intermediaries capture value and dictate rules. Holochain ensures that neither the data nor the rules of interaction are held by third parties. Your digital life is centered on you.
This infrastructure is designed to serve the flourishing of people and planet rather than extracting from it. It is a technology built not for centralized control or surveillance, but for enabling communities to create and govern their own spaces, creating what the sources refer to as truly decentralized commons enabling infrastructure.
We spent the first few decades of the digital revolution building systems based on a fundamental misapprehension. The impossible assumption of simultaneous global agreement. The result was brittle, slow, and enormously expensive infrastructure.
Holochain shows us that the most robust and complex systems, the natural world, thrive on decentralized coherence built from localized, rapid validation. The ability to create these engagement spaces with custom, evolvable rules provides the mechanism for a robust social organization to emerge from simple, local principles.
So if our digital infrastructure is simply a reflection of our collective values and our organizing principles, we have to ask ourselves, what kind of world are you ready to build now that the blueprint for a truly decentralized, self-healing ecosystem, modeled after life itself, is available?
We've seen the power of local autonomy constrained by transparent peer accountability. The higher level question remains, what kinds of scalable, adaptive, and desirable social possibilities can these technologies enable when we move beyond the outdated notion that power and coherence must be centralized and rigid?
Think about the potential of a self-healing, adaptive digital future where the rules are yours and the network can survive any localized storm. That was the deep dive. We'll see you next time.